Hey 8th graders, welcome to iReady Lesson 2, Session 2. This starts on page 21 in your books. And we are performing a reflection on the coordinate plane. So yesterday we did a translation on the coordinate plane where we just slid it. Now we are doing a reflection where you flip it. Okay, in fact you can put a note for yourself up there. Flip. But I think you already knew that because you got the mirror analogy very well. You know, in a mirror it flips, so its reflections flip. Okay, Alyssa is making a paper dragon puppet as part of her family's Chinese New Year tradition. She lays her tissue paper over the coordinate plane. Then she draws figure WXYZ. I just really like to color them. For one of the dragon's eyes. Okay, see it's up here. But the other eye can't go the same way because then it would be a weird looking dragon. So, to make the other eye, she reflects figure WXYZ across the x-axis to form the image. Remember, image beats copy. I'm going to add that too, just because I can. Copy what the image is. There you go. To figure W prime, X prime, Y prime, Z prime. That's fun to say. What are the coordinates of the vertices? Vertices, remember vertices? You did that for your vocab page yesterday. It means corner. What are the coordinates for the corners of figure W prime, X prime, Y prime, Z prime? Okay, so we have to flip this thing over. The x-axis. The x-axis is our line of reflection. So remember, that's going to be our middle. Line of reflection is the middle. So Y is one space away from X. So Y prime is going to be one space on the other side. There's Y prime. And you can keep doing the same thing. Z is 1, 2, 3 spaces away from X, from the x-axis I should say. So Z prime is going to be 1, 2, 3 spaces away on the other side. Same thing with W. W is 1, 2, 3, 4, so I'm going to go 1, 2, 3, 4. W prime, and X is 1, 2, 3, 4 as well. 1, 2, 3, 4. X prime, and then I'm going to connect my dots. There's the other eye for the dragon. It's a little sloppy, but I think I did a pretty good job. So now it's asking what are the coordinates of the vertices. So we're just going to have to figure out what they are. Okay, so we have we want to go in alphabetical order. I know my alphabet still. W prime, X prime, Y prime, Z prime. Okay, and let's just look at them. Okay, W is at, we do the X first because X comes before Y in our ABCs. So W is at -3, -4. -3, -4. Point X prime is at -1, -4, -1, -4. Y prime is at -2, -1, -2, -1, and Z prime is all the way over here at -4, -3, -4, -3. And yes, I'll put the equal sign there. I know it's bugging you. It's bugging me. Gotta be consistent. right? Okay, so now it's going to ask us probably what? Oh, no. Oh, it's got the dragon here. That's beautiful. Okay, so they also did it just on here. And the first method they're giving us is picture it, which is the one that we did. We just kind of actually drew it, didn't we? And that worked out nicely, but we're also trying to figure out how this affects the numbers for the points on the coordinate plane. So let's look at our model it and make a little table here. Okay, so let's look at the differences. We're reflecting across the x-axis, right? This flip here. So the y's, the x coordinates aren't changing. See, it goes through the x at the same spot. But the y's are changing by a lot. In fact, if you look here, you'll see they are changing by the opposite on this particular example because they're going right across the x. So this stayed the same, but these are the opposite. X is the same, y is opposite. So x is the same on both of these, y will be the opposite. So let's fill those out. This is y prime, and that's the same, and that's the opposite. Z prime, that's the same, that's the opposite. Ta-da! Alright, I really like that dragon. It looks nice. Okay, use the problem from the previous page to help you understand how to perform a reflection in the coordinate plane. So we're going to look at the picture at how does the distance of each vertex, remember vertex means corner, of the original figure, W, X, Y, Z, to the line of reflection, which in this case was the x-axis, that's what we reflected across, compared to the distance of its corresponding vertex of figure W prime, X prime, Y prime, Z prime. So let's look at the distance. How does the distance of the corresponding vertex, how do they relate to each other? Okay, so let's check. Well, here's the corresponding points y and y prime. This one's one space away from the line of reflection. This one's one space away from the line of reflection. Z and Z prime. 1, 2, 3 spaces away from the line of reflection. How many spaces away do you think Z prime will be away from the line of reflection? If you said 1, 2, 3, then you're good to go. You figured this out. Let's look at W and W prime. 1, 2, 3, 4. You can probably figure out by now it's 1, 2, 3, 4 on the other side. There we go. I'm not even going to do X because I think you already figured it out probably. Okay, so what are we going to put here? Because we can talk about it, but we want to be sure that we can articulate it in writing as well, because that's being able to express yourself in writing is a very important skill. So let's give it a try. Should I use my text tool for this one? I feel like I should. Let me use my text tool instead of making you watch my sloppy writing. But can I make this a little bigger? There we go. Okay, I'm going to say each vertex of the image, remember image means the copy, is the same distance from the line of reflection as the corresponding vertex of the original figure. Oops, vertex of the original figure. And that's just the proper math vocabulary way of saying the points that go together are the same distance from the line of reflection as each other. Okay, for number 2 it says look at model it, and what are the coordinates of y prime and z prime. Complete that table. We already did that. Goodness sakes, why wouldn't we do that already? Okay, see, we did it right here. These ones. It said go back and do that, but we did it. Yep. Oh no, you need to be down. Let me fix that. That's better. Okay, the table shows how the coordinates of a point change when it's reflected across, and this is very specific here. When it's reflected across the x-axis or the y-axis, not just any line, not just any line in the coordinate plane, but specifically across one of the axes. Describe how the coordinates of a point change when it's reflected across the axes. And we already kind of talked about this, right? Where the original, if it's reflected across the x-axis, then the x isn't changing because it's going up and down. Up and down means that the y is changing. But now over here, we've got this one, we've got the x, or the y, when it's reflected across the y-axis, it's going side to side. Let me draw that really quick. Here's a point, here's a little triangle. When it reflects across the x-axis, it's going up and down, so these will change, but these will not. If it's reflecting now across the y-axis, these aren't changing, the y coordinates aren't changing, but now the x's are the opposite because it went sideways. Okay, so if it reflects across the x-axis, it's going up and down, so the up and down coordinates will change. If it's reflecting across the y-axis, it's going side to side, so the opposite of what I said. The up and down, the side to side coordinates will change because it's going side to side. Same thing for all of these. If it's going across the x-axis, it's going up and down, so the up and down coordinate will change. The y is the up and down. If it's going across the y-axis, it's going side to side, so the side to side will change. Remember, x is side to side, y is up and down. I'm really doodling a lot today, aren't I? Okay, describe how the we have to describe it now. Let's see, how do we want to describe that? Let's see, I'm just going to say, across the x-axis, the x coordinates are the same and the y coordinates are opposite. Across the y-axis, the x coordinates are opposites, but the y coordinates stay the same. And yes, I did copy paste that from the teacher's edition, but you know, it's a really good answer. Okay. Pause if you need, remember, pause if you need to write stuff down. And you can shorten words and stuff. But this is good practice for when you need to write it formally. What are the coordinates of point xy when it's reflected across the x-axis? When it's reflected across the y-axis, so point xy could be anything. It's point xy, it's a mystery. Well, I wish they'd use different variables for this one, I think. Okay, so when it's reflected across the x-axis, then what changes? Across the x-axis, the x coordinates stay the same, and the y coordinates are opposites. So it goes across the x-axis, it will become x coordinates stay the same, y coordinate is the opposite. Now let's go across the y-axis. The y coordinate stays the same, but the x is the opposite. And we're just going to very briefly, because this is explain, and we always must explain when it says explain, no skipping, explain why only one coordinate changes when you reflect it across the point, or when you reflect it across an axis. Because it remains the same distance from the axis it's reflecting. the same distance from the line of reflection, I'll say. Okay. Okay, now think about all the models and strategies you have discussed today and describe how one of them helped you better understand how to solve the triad problem. So you're going to go up here. Whoop, I moved my thing again. Stop moving your answers. Jeez. You're going to go up here and you're going to look at the picture it and the model it and decide which one you prefer. Do you prefer drawing it out, or do you prefer looking at it and doing the math? And you're going to put down here for number 5 which one you prefer. So give me a little pause here and go ahead and answer that, and then unpause when you're done, because this one's your opinion. Okay, now that you've answered number 5, we have, let's see, 6, 7, and 8, and then your practice pages are down here. Okay, Seth reflects triangle ABC across the x-axis to form DEF. Oh, look at that. They're not going to use A prime, B prime, C prime. How dare you? You just taught us how to do that, and you're not even going to do that. Let's draw DEF. What are the coordinates of the vertices? Okay, so we're going to flip it over across the x. Remember, this is the x, this one. So it's going to go across this way. So point B, 1, 2, 1, 2. Point C, 1, 2, 3, 4. I'm getting too many dots, for goodness sakes. 1, 2, 3, 4. 1, 2, 3, 4. Make them bigger so that they stand out more. 1, 2, 1, 2. There we go. We built a reflection. There we go. And then DEF. So I'm going to try to keep it also in ABC order. Since ABC order goes A, B, C, I'm going to go D, E, F. Okay. And then I've got D, E, F. And what is it going to be? I'm going to switch colors again. But then this is going to bug me. There, that's gone now. I'm going to switch to black. So D is at 1, 2. 1, 2. E is at 3, 2. 3, 2. And F is at 3, 4. Yes. Gold star. Smiley face. Good job. Alright, same deal here. Isabel is planning a design that uses different colored wooden triangles. She starts drawing her original triangle JKL in the coordinate plane. Then she reflects JKL across the x-axis to form J prime, K prime, L prime. Draw J prime, K prime, L prime. What's that one harder to say? In the coordinate plane, what are the coordinates of the vertices? Okay, we're going to do the same deal here. We're going to go 1, 2, 1, 2. This one's just on it. There's 0. I don't have to move that. Then we have 1, 2, 3, 4. 1, 2, 3, 4. Ta-da! And now we can connect the dots. Best part of the day, connect the dots. Yeah, oops, that's terrible. I'm redoing it. There we go. Okay, so x and x prime, ta-da, they're the same. Isn't that nice? There's, wait, not x. I'm looking at that little x right here. Get out of here, you're distracting me. Oh, I know I can do. Aha, I cheated. It's gone now. Okay. There we go. This one's L prime. K prime. J prime. So now we need the points for J prime, K prime, L prime. I did the same thing again. I want to go back to black. There we go. Okay, so now we just have to figure out what our coordinates are. J is at 0, -2. 0, -2. K is at 1, 2, 3, 4, -4, 4, -4, and L is at the same spot as L. L prime is at the same spot as L, so that's what, 4, 0. Hooray! Alright, last one. Malik draws a quadrilateral. Remember, quadrilateral means 4 sides. Quad means 4, just like, you know, quad, vroom vroom, has 4 wheels. But then lateral means lines, 4, so it's got 4 lines. Okay, quadrilateral STUV in the coordinate plane with the no grid for this one. So the vertices are right there, right there, right there, and right there. Then Malik reflects quadrilateral STUV across the y-axis. So we're going across the y. So remember, going across the x, we're going up and down. So going across the y, we're going to go side to side. Okay, to form quadrilateral S prime, T prime, U prime, V prime. What are the coordinates of the vertices of quadrilateral S prime, T U prime, U prime, V prime? Show your work. We always show our work. We're diligent students. Okay. So, what did we discover up here? If you forget, guess what you can do? You can go back and look. What did we say up here? We said across the y-axis, the x-coordinates are opposites, the y-coordinates stay the same. So our y-coordinates are going to stay the same and our x's will be opposites. Did I just move a highlight? That's going to bug me. There we go. Okay. So S prime our x is the opposite. Our y stays the same. Look how we show our work by just putting the answers. We're so clever. T prime x is the opposite. Y stays the same. U prime x is the opposite. And y can change anyway, right? Because you can't. There's no such thing as -0. V prime x is the opposite. Y stays the same. There we go. Because it's going side to side. It's not changing. The y coordinates are not changing because it's not going up and down. Okie dokie, and that is it for the lesson. Now, the pages that you're going to photograph for Canvas upload are 25 and 26. And you're going to be really careful on number 3 because you need to tell whether each statement is true or false. So take your time and really think about these ones. And if you get stuck, guess what? Your parents have the answer keys. Actually, you do have the answer keys? You might have the answer keys too. If you don't have the answer keys, make sure you email your teacher and get the answer keys. And, yeah. See you tomorrow.